Dust isn't falling, it's dancing, and gravity can't stop it. You've seen it, that shaft of light through your window, thick with particles that seem to drift upward. Most of us assume they're sinking slowly. We're wrong. What you're watching isn't gravity winning. It's gravity losing a battle it doesn't know it's fighting. The particles in that beam are typically between 1 and 100 micrometers across. A human hair is about 70 micrometers wide. So we're talking about fragments smaller than the thickness of a hair, sometimes far smaller. At that scale, the rules change. Here's what most people don't realize. When something gets small enough, air stops being empty space. It becomes a medium, a crowd. Billions of air molecules surround each dust grain, colliding with it from every direction thousands of times per second. This is called Brownian motion, named after Scottish botanist Robert Brown, who noticed it in 1827 while observing pollen grains under a microscope. The pollen didn't drift. It jittered, jerked, moved randomly in all directions at once. Brown had no idea why. He wondered if the pollen was alive, moving itself. It wasn't until nearly a century later that physicists understood those random collisions from invisible air molecules were strong enough to overcome gravity. They were literally holding the dust up. Think of it this way. Gravity pulls down with steady, constant force, but air molecules hit from all sides, left, right, up, down, unpredictably. A dust grain is so light that these random impacts can push it upward just as easily as gravity pulls it down. It's a fair fight. The smaller the particle, the stronger this effect becomes. A grain of sand, it falls. A speck of dust, it floats. A smoke particle, it practically refuses to settle. The ratio of surface area to mass inverts everything we learned about objects and weight. This is why dust is so hard to clean. It doesn't want to fall. Sweeping stirs it up. Wiping redistributes it. The air itself is protecting it. You're fighting physics, not laziness. Back in the sunbeam, what you're witnessing isn't a slow fall. It's a random walk. Each particle moves erratically, nudged by molecular collisions, sometimes drifting up, sometimes down, but never settling into a predictable path. It's chaos, beautiful mathematical chaos. The physicist Albert Einstein published a paper in 1905 that mathematically explained Brownian motion. It wasn't just elegant theory. It became proof that atoms and molecules actually exist. Until then, some scientists still debated whether they were real. Dust dancing in sunlight had become evidence of the atomic world, a phenomenon so ordinary that billions of people watched it without seeing it, without knowing they were witnessing proof of something fundamental about reality. This principle extends far beyond dust. Pollutants in the air hang suspended for days. Smoke rises and spreads. Fog refuses to simply fall. All of it, everything tiny enough, is held aloft by the molecular jostling of air itself. The particles that trigger allergies, pollen, mold spores, dust mites float on these same invisible currents. They don't fall onto your pillow because gravity was too weak. They settle because eventually they bump into something solid. A surface, your skin, your lungs. Engineers use this knowledge to design air filters, clean rooms, and ventilation systems. They account for Brownian motion because ignoring it means your filter won't work. The invisible dance isn't poetic, it's practical. It matters. Next time you see dust in a sunbeam, pause. What you're really watching is billions of air molecules playing tug-of-war with gravity and winning. It's not a flaw in physics. It's physics working exactly as it should at a scale we rarely think about. The ordinary world is full of these hidden mechanisms. Tiny forces we can't see, operating at scales we rarely consider. And they're happening right now in your room, in the light coming through your window. You just have to know where to look. Subscribe so you don't miss the next time the everyday world reveals its hidden physics.